I am Karl Philippoff. I'm a weather observer, research, and IT specialist up here on Mount Washington. For one of the research projects that I've been working on is the Near-Surface Lapse Rate project. A lapse rate is a change in a variable with changes in altitude. And so for a near-surface lapse rate, you're keeping that surface with you as you go up that slope. So the difference between the two is that for a lapse rate, you're looking generally into the free atmosphere. So you have a flat surface and you're going up and up and up. And for a near-surface lapse rate, you're basically going up a slope of a mountain. So you're keeping your thermometers or any kind of variable at 2 meters above the surface, and you're kind of following that slope up the mountain. So specifically for this research, we'll be looking at air temperature. So looking at air temperature at about 2 meters above the surface, about 6 feet, and looking at how that changes over time. And as for this, we've been using the stations up the autoroad. So we have stations every roughly 1,000 feet going up the autoroad. And we have minute data going back to 2016. And so we've been looking at the last 7 years of data, both the maximum, minimum, and the average temperatures at these stations, basically what a seasonal or climatology is like going up the summit. This is a very unique data set because we're the only station that has been instrumented for that long and has better than 99% data completion over roughly a 7-year period. And so this can actually be used for modeling research and also for our own forecasts up here on the mountain to improve our precipitation forecasts for where that rain snow line might set up. Temperature modeling within complex terrain, which is basically mountainous terrain, so where we are in Mount Washington, has not been done so much on the eastern part of the US. It's been done a little bit more in the western. And so we have one of the best data sets for the eastern US for that, for temperature, especially temperature, multiple stations on the same mountain. And so that's why our research can be better applied to, like, let's say not just in the White Mountains, but also in the Hoosics and also in the Green Mountains in Vermont. And so having our data set over that long time period can better characterize our climate up here in the northeastern US.